Good morning, and thanks for coming to the Data Colada seminar series. I'm Leif Nelson, and it is my pleasure to introduce today's speaker, Josh Lewis. In addition, we're joined by a series of outstanding panelists, Julia Minson, Derek Kohler, Hannah Perfecto, Clayton Critcher, and Dan Schley. Furthermore, in addition, today we have Joe Simmons and Yuri Simonson, who will be with us as well. All of us will be hopefully asking questions and offering comments to Josh as he goes, but for all of you out in the audience, you can submit questions and comments through the Q&A function at the bottom of your screen. Josh won't be able to read them, but the rest of us will be, and when possible, we will give voice to them in the session, but even if we don't, they're all recorded, so Josh will be able to read them at the end of the talk, so don't be afraid to put them in, even if it doesn't seem like we're getting to them. All right, and so with all of that, Josh, the floor is yours.
Thanks, Leif. Okay, so actually, I'm gonna share a different way. Just one sec. Okay, so I'm going to be presenting an anchoring paper that Joe and I were working together on when I was doing my PhD. I'm presenting this mostly as an elaborate ploy to get Joe to remember the project exists. Naturally, as I'm presenting work with my advisor, it's traditional to say that all the good things about this project really are all me. But if there's anything that seems a bit off, any jokes that don't land, any dodgy p-values, any gratuitous sites of intuitive confidence, I tried to talk Joe out of it, but yeah, he insisted. So, all right, I'm going to start by just going over what anchoring effects are and the classic account of them, which is insufficient adjustment. Okay. So imagine, for example, that you are estimating the length of the River Nile in miles, and absent an anchor, you'd make an estimate at that blue arrow. But now imagine that before you make this estimate, somebody asks you whether the length of the Nile is longer or shorter than a high anchor of 5,000 miles. According to the traditional insufficient adjustment account of anchoring, you would start adjusting your estimate from this anchor, but insufficiently. So you stop adjusting before you get to your unanchored estimate and end up estimating something higher than that unanchored estimate. And this could either be because the adjustment process is effortful, it could be because your numeric scale is distorted by the anchor, it could be because of extremeness aversion. Either way, these are all kind of dry cognitive accounts, and I'm going to try in this talk to add another perspective on anchoring, and to kind of motivate this and describe what I mean. I'm actually going to start by showing you a video of a trust exercise. Now, as you watch this video, see if you can see the kind of analogy to insufficient adjustment.
Fall, and it'll be an exercise in building trust between one another. So Harrison, if you don't mind going first, step up here on this chair and close your eyes. All right, and then everybody fill in, and we're going to ask you to fall, and then they will catch you. So you have to trust us. So I'm going to count to 3, just relax and fall, okay? 1, 2, 3. No, wait, no!
Okay, in anchoring, as in trust exercises, direction matters. So to see what I mean by this in an anchoring context, let's go back to the same example as before. Now, recall that you're asked this question of, is the Nile longer or shorter than 5,000 miles? And the traditional anchoring literature kind of presumes you'll adjust from the anchor in the right direction. But of course, as long as the anchor is in kind of the range of plausible values, you're not going to know, first off, whether the true value is higher or lower than the anchor. In which case, it's possible that because, well, the Nile is a very long river, you might actually adjust your estimate higher than the anchor, even though without the anchor, you would have estimated something lower. And if you do this, this is going to cause an even bigger anchoring effect and could have been explained by insufficient adjustment alone. Okay, so the plan for this talk first is just to get a rough sense of how prevalent are these opposite direction adjustments. Then I'm going to offer a theory of how people decide in which direction to adjust from anchors. And then I'm going to go over some kind of practical implications of this. All right. So let's start with kind of addressing the prevalence of these wrong direction adjustments. To do this, I'm going to use a relatively neutral estimation task. Essentially, I'm going to get people to estimate either the proportion of red or blue pixels in an image very like this. They're going to be incentivized estimates. And participants are going to make kind of many estimates in the same survey. So I'm going to use a range of images like this one with the proportion of red versus blue pixels varying from kind of very low to very high. Okay, so that's all the images. There were 20 images I showed you in total. What might not have been obvious there is that there are in fact only 10 images. I just showed you each of the 10 images twice. Because these are just scrambled pixels, it's really hard to recognize if you've seen that same image twice, which is cool because it allows us to get a within subject measure of the anchoring effect. So one time when we ask people to estimate the proportion of red or blue pixels in that image, there'll be an anchor. And the other time, they'll estimate the same thing without an anchor. And that allows us to not only to measure kind of the anchoring effect for each observation, but also to see whether they're adjusting from the anchor in the same direction as their unanchored estimate or in the opposite direction. Okay, so to remind you, participants make incentivized estimates for the proportion of red or blue pixels in each image. And the correct answers range from about 7.5% to 92.5%. So we have a kind of range of correct answers. To select the anchors, we ran a pretest with about 200 participants, and we basically selected anchors for each stimulus from the 5th percentile, 15th percentile, through to like the 85th percentile and 95th percentile of pretest estimates. Okay, so I'm just going to give you an example of what participants would see in the anchoring condition. So they'd see the image. In the middle of the screen there, I have the higher or lower question, are more or less than 64.5% of pixels in this image red, in this case. Now, we'd only need to ask this question for the anchored estimates in the unanchored condition, of course. They just wouldn't answer that question. And then finally, they'd give their answer in a text box like that. Okay. Again, the idea of this is just in a relatively neutral setting with kind of diverse range of correct answers and anchors, just to see how often of the time are people adjusting their estimates from anchors in the opposite direction of their unanchored estimate.
Sorry,
oh yeah,
Josh?
go on. Yeah, go on.
Do you offer them any explanation for why you're giving them that percentage estimate, why they're being asked? Are there more or less than 64%? I'm mostly wondering whether they think that's informative.
No, we don't give any indication. So I think in this study, it's plausible they think the anchors are informative.
Thanks.
Josh, can I ask another question?
Yeah, go on.
So kind of conceptually, what do you think is happening with the unanchored estimate? So like, is your idea that there's an unanchored estimate that's sort of hanging out in their head before they give the second anchored estimate, and it's just sort of like vague and they don't say it? And if they have something in their head, then why would they adjust in the opposite direction of it? And if they don't have it in their head, then what do we mean by unanchored estimate?
Okay, yeah, so this is a good question. So what I suspect is that people don't have their unanchored estimate in their head for each image. So what we're trying to do here is we're actually just trying to, by the unanchored estimate, we just mean kind of what they would have estimated without an anchor. We're not saying they necessarily know what that is after they see an anchor. Does that make sense?
Yeah, so I think what got me going on this is your number line and the idea of being in the wrong direction of something that doesn't actually exist yet.
Yeah. Yeah.
I was confused.
Okay, yeah. So that makes sense. So it's in the opposite direction compared to like in the counterfactual case, had they not seen the anchor, what they would have estimated, but they don't necessarily know it's in the wrong direction. If that makes sense.
Thank you.
I asked a question too while we're asking about.
Yeah, of course.
I was kind of surprised, given your introduction with the example of the Nile. I was kind of surprised to see you chose like a judgment that's on this kind of bound scale like that from 0 to 100. And it seemed like particularly if you want those different percentiles of the, distribution of estimates, like if it's like a target where it's 92% red pixels, and then you want to get the 95th percentile of that distribution, aren't you going to gets kind of crowded on that end of the scale, right? It seems like it's a difficult area to work in. So I wasn't sure what the rationale was for that.
Yeah, so one of the nice things about percentage estimates is it's reasonably easy to get quantities that are kind of unambiguously high and unambiguously low, which we'll kind of talk more about later. The other nice thing about these things is that there are correct answers, so we can kind of analyze accuracy as well, which I won't go through too much in this talk. But essentially, you're right that like the high anchors get relatively kind of for a 90% estimate. Yeah, the high anchors are kind of relatively bunched together, and and the low anchors can be a bit more sparse, so they're kind of skewed a bit. That's not going to matter too much for what I'm going to show you. And I'm also going to kind of later on in the study use some unbounded willingness to pay judgments as well, and show you how those work. Okay. So I motivated this by trying to say we're just going to look at like the proportion of adjustments that are in the opposite direction of what people estimate happens to an anchor for the same stimuli. And basically we find people are adjusting in the opposite direction around 23% of the time. And because there's kind of a lot of observations, we're estimating that relatively precisely. Okay, so I'm not going to, for this data, kind of try to offer an account of exactly why and how they're adjusting in the wrong direction yet. The point of this is just to say this is happening frequently. It's happening kind of more frequently than would happen by chance, which you can show by kind of permutating the anchors. It's happening more frequently than be predicted by a kind of pure insufficient adjustment type account, which wouldn't predict that you get these estimates in the opposite direction. But there are potentially other factors that could cause this kind of result, like noise. The point is just to motivate that it's important to understand how people decide which way to adjust from anchors. And doing so should help us understand when anchors are most influential and generate some implications of anchoring. Okay, so go on.
Josh, one more question, sorry.
Yeah.
So you asked them in the anchored version if it's higher or lower than the anchor, right? Have you looked at how consistent their response to that is with the estimate they give in the unanchored version of the question?
So I can't remember looking at that question instead of the final estimate. But I would presume it's fairly similar to the estimate. So it would be kind of odd if they're saying, say, I think it's higher than, say, 63%, but then they're giving an estimate that's lower than 63% on the same page. So I think most of the time it will just be consistent. So often they will give a kind of inconsistent response to the higher or lower question compared to their unanchored estimate. Does that make sense?
Yeah, so then the idea of adjusting in the wrong direction could be sort of interpreted as like adjusting in the wrong direction relative to what they just said to the higher lower question.
Oh, okay. So yeah, so that's yeah. So I haven't thought about that, and I can have a look at how similar the anchored estimates are to the higher or lower question. But yeah, I was trying to define adjusting in the wrong direction in this case, or at least in the opposite direction relative to the unanchored estimate. So they have an unanchored estimate, they have an anchored estimate. and we're just trying to see if those two things are on kind of different sides of the anchor, then we'd say the estimate is adjusted in the wrong direction, or the opposite direction at least.
So Josh, just to take one small step back, so all of this is under the presupposition that people are adjusting. And there's been somewhat mixed evidence in the literature about whether or not adjusting occurs. You know, one complaint I've always had about this literature is that researchers often study anchoring under the assumption that adjustment occurs, and they oftentimes don't build the theory around how does the judgment occur without the presence of the anchor. And this calls back to Julia's earlier question. Fundamentally, in the unanchored condition, how are people creating their answers? And fundamentally, what then changes when an anchor is present? And so are they adjusting from something in the initial unanchored judgment? And is this now, does the anchor change the point of adjustment?
Yeah, so that's interesting. So there could be kind of some anchor that they're starting from in the unanchored case. So there could be some, say, yeah. So it's possible that like people are actually making judgments anchored at 50% in the unanchored condition, and it's interesting to think about like what implications that might have for like how people actually adjust from anchors when they're actually present, and how that will be inconsistent from the estimates in the control condition. But I think that's a good point, and I think that yeah, it would be interesting to consider how that would interact with our findings later on. Okay. So for now, I'm going to start kind of developing the theory of how people decide in which direction to adjust from anchors when they see them. Okay, so the idea is that when somebody compares the length of the Nile or some quantity like that to an anchor, let's say a high anchor of 10,000 miles, they must consider the hypothesis that it's shorter than 10,000 miles, or secondly, the hypothesis that it's even longer. But in the case of the Nile, well, the length of the Nile is an intuitively large quantity. It's easy to think of reasons why it might be larger than 10,000 miles, including that it's the longest river in the world, or that it spans multiple countries, etc. And when people kind of think about reasons or why a hypothesis might be true, that hypothesis tends to seem more likely. So by considering this question of is the length of the Nile longer or shorter than 10,000 miles, just by thinking about this question, it makes that possibility that it's longer seem more likely, and it makes people more likely to adjust higher than that high anchor. So in other words, I think about the question and therefore I anchor. So actually, the philosopher Descartes anticipated this result all the way back in 1637. Okay, so to flesh out in practice how this psychology can cause anchoring, I'm going to kind of go through the case of low anchors, then high anchors, and consider both kind of intuitively low quantities and intuitively high quantities as I go. Okay, so if an anchor is lower than what your unanchored estimate would have been, but you're estimating an intuitively low quantity, it's possible that you'll be able to think of many reasons why this quantity might in fact be lower than the anchor, in which case you might still adjust lower than the anchor away from what your unanchored estimate would have been. To make this more concrete, imagine that you're estimating the weight of a mouse, and absent an anchor, you'd be estimating something in the middle of the kind of perceived range of reasonable estimates there. But now imagine that you're given a low anchor at that black bar. Now, because mice are kind of intuitively small, it's easy to think of reasons why the weight of a mouse might be lower than a low anchor. So it's possible that you might adjust your estimate from that anchor lower, causing an even bigger anchoring effect than could be produced by insufficient adjustment alone. So in this case, people adjust lower than a low anchor, kind of away from their unanchored estimate. But now consider the case of a relatively low anchor compared to the range of reasonable estimates, but paired with an intuitively high quantity like the weight of an elephant. Well, because elephants are kind of intuitively heavy, it's not going to be as easy to think up reasons why the weight of an elephant might be lower than an anchor. So in this case, we probably expect people to adjust upwards from the anchor towards that unanchored estimate. So in this case, we don't expect a directional anchoring bias. We just expect classic insufficient adjustment towards that unanchored estimate. So either people are adjusting kind of lower than the low anchor, or their adjustments are kind of consistent with that unanchored estimate. So kind of on aggregate, we're going to get a bias towards adjusting lower than low anchors. We can kind of think through the same process for high anchors. So if an anchor is higher than what an unanchored estimate would have been, but you're estimating an intuitively high quantity, it's going to be easy to come up with reasons why that quantity might be higher than the high anchor. And so you might still adjust your estimate higher away from what your unanchored estimate would have been. So let's consider again the example of estimating the weight of an elephant, this time with a high anchor, higher than what your unanchored estimate would have been. Well, easy to think of reasons why the weight of an elephant might be heavier than that anchor. So it's possible that some people are going to adjust their estimate upward from that anchor, again creating a bigger anchoring effect than would be due to insufficient adjustment. So in general, with high anchors estimating intuitively high quantities, people might adjust higher than a high anchor away from their unanchored estimate. In the case of an intuitively low quantity and a high anchor, well, here it's going to be tough to come up with reasons why the weight of a mouse is going to be higher than some high anchor. Mice don't feel like particularly large creatures. So more likely you're just going to adjust your estimate back towards your unanchored estimate, possibly insufficiently. So in this case, people simply adjust towards the unanchored estimate. And so on aggregate with high anchors, you're getting more people adjusting higher than the high anchors. But this is going to be mostly driven by intuitively high quantities. Okay, so I'm going to test this theory in study 2. For this, we recruited 341 participants in the Wharton Behavioral Lab. They made 20 incentivized estimates, 10 of intuitively low quantities, 10 of intuitively high quantities. There were 3 within subject's conditions, so either people made unanchored estimates, or they made estimates with a low anchor or estimates with a high anchor. And these anchors were kind of drawn from pre-test estimates to approximate the 15th percentile of those estimates in the case of the low anchor, or the 85th percentile in the case of the high anchor. And these anchors were kind of informative to Leif's question earlier, but we did actually kind of replicate this study with transparently uninformative anchors as well. Okay, so in terms of the design, in the case of estimating an intuitively low quantity, we might ask, well, what percentage of American adults have PhDs? That should be an intuitively low quantities, not because I'm calling Americans dumb, not at all, just because very few people have PhDs in any country. Now, in the low anchored condition, before people answered this question, we'd first ask, do more or less than 2.5% of American adults have PhDs? In the high anchored question, we'd use something like 22.5%. In the intuitively high quantity condition, we'd ask something more like what percentage of American adults own a mobile phone. It's going to be an intuitively large number. For the low anchor, we'd use something like 67.5%. For the high anchor, we'd use something like 97.5%. Okay. So I'm going to show you results for the low anchor on this chart. The y-axis is just showing the percentage of estimates that are lower than the low anchor. On the left, I'm going to show you intuitively low quantities. So around 20% of the unanchored estimates are lower than this low anchor. But when people are actually asked to consider the low anchor, it's easy to think of reasons why these intuitively low quantities might in fact be lower than that low anchor. And so we see 43% of people adjusting lower than that low anchor. That's a big effect, but of course, in this talk, size is not what matters. It's the direction that counts. And of course, it's in the right direction. Now, for intuitively high quantities, we don't see any effect. And that's not surprising because it's hard to think of reasons why these intuitively high quantities would be lower than the low anchor. Now, this moderation is important, and it potentially answers Dan's question from earlier, or at least speaks to it to some extent. So there could be some theory whereby the reason this is happening is because in the unanchored condition, there is in fact some other reference point like 50%. So in fact, maybe people's estimates are kind of anchored to 50%. But in that case, it would be, and so that could mean that kind of people's estimates were too far from the anchor in the unanchored condition, and that could explain why more people are kind of below the anchor in the anchored condition. But that's hard to explain then why the effect is so much bigger for intuitively low quantities. Okay, so now we're going to think about the proportion of estimates that are higher than high anchors. So that's what the y-axis is going to be on this chart. So for intuitively high quantities, we're going to expect that difference between unanchored and anchored estimates. Basically, when people see a high anchor for an intuitively high quantity, it's going to be easy for them to come up with reasons why that intuitively high quantity might be higher than that high anchor. And consistent with that, we see only 13% of estimates higher than the high anchor in the unanchored condition, but 30% of estimates are higher than the high anchor in the anchored condition. And for intuitively low quantities, this effect is moderated. Okay.
Josh, can I ask a question?
Yep.
I'm thinking about a connection to a phenomenon that seems superficially different, but I'm wondering if it's the same psychology. So I'm thinking about like Clar's work on comparative judgments, that if I compare X against Y, it really becomes a commentary on X and not Y, so if I think, how is this Nobel Prize winner smarter than the average Nobel Prize winner, I tend to say yes. So there, the focus historically has just been on showing this systematic bias where I say most people in a positive group are above average. Whereas in the anchoring literature, the focus hasn't been as much about answering these questions, but the final answer. But essentially, are you sort of marrying those two phenomena and say, actually, that first judgment is sensitive to sort of Clar-like effect, and then as a result, that produces this anchoring effect?
Yeah, that's pretty much exactly it. So you can even think, imagine a case in which there was an extreme version of that bias where, say, you're estimating the weight of an elephant, you just always say it's higher than whatever quantity you're given. Then basically what the anchor would do is act as a kind of minimum estimate, and so the higher the minimum estimate, the higher average estimates would be. So yeah, I'm basically saying that process kind of systematically contributes to anchoring.
Can I ask a question as well while we're chatting here? Just quickly, there are a couple of questions from the audience that are kind of relevant as well about how you define like an intuitively high versus low quantity, since presumably it's kind of all relative, right?
Yeah.
So an elephant weighs a lot compared to a mouse, but not to a 747, I think was the example from the audience. And I'd kind of relatedly ask why you want to label these as intuitively low. I mean, they're kind of objectively high or low on the scale that you're using, and presumably the mean judgments follow that. So why call it intuitively?
Yeah, so that's a good question. I think the psychologically important thing is people's intuitions about the quantity. Another way to think about it would be like, well, when you're kind of comparing something to another quantity, is it easier to think of reasons why it might be large, or easier to think of reasons why it might be low? It's kind of easy to come up with things, especially on the percentage scale, that are both actually high and intuitively high. In the I'm going to show you a willingness to pay study in study 3, where that although we'll use kind of intuitively appealing and intuitively unappealing products, which will probably correspond a bit to cheap and expensive products. But the important thing again is going to be kind of people's kind of subjective intuitions, which should be driving the effect.
Josh, one more question kind of related to the mechanism question that Clayton
Yeah.
asked, and also related to Leif's earlier question about what people think these anchors are. I wonder if the thing feels intuitively high and then, you know, an experimenter asks you to compare it to a high number, do they treat that as sort of consensus that, you know, some other person thought that this is a high thing? And have you ever done anything where you say, you know, we pulled a number out of a hat and it happens to be this?
Yeah.
High or low?
Yeah, that's right. So we replicate this with transparently uninformative anchors in a MTech study, and then for the willingness to pay study I showed you as well, we do something where we use two anchors, and the anchors are informative, but so we use that is a high and a low anchor, and then what we do is for all participants we tell them these are the two possible anchors you could get, and we're going to randomly select one of them. So everyone has the kind of same information. In this study, though, that the possibility that the anchors are informative is there, and so yeah. But I think that it is possible that like the kind of informativeness of the anchor would produce something like this effect. But that said, it's kind of harder to think why that would cause this interaction. But it is possible. But yeah, as I say, we use transparently uninformative anchors in other studies.
Thank you.
Okay, so so we have some like account of like when people are most likely to adjust in the opposite direction of unanchored estimates, or at least when they're likely to adjust higher than high anchors and lower than low anchors. Now, of course, like adjusting higher than a high anchor should cause a bigger anchoring effect than just insufficiently adjusting downwards. And so this pattern should help us say something about when anchoring effects will be largest. So on this chart, I'm just going to show you anchoring effects on the y-axis. And I'm going to do this analysis separately for kind of the intuitively low quantities on the left and the intuitively high quantities on the right. And I'm going to compare the effect of low anchors versus control and high anchors versus control for each of those kinds of quantities. Basically, what we're going to expect is for low anchors for intuitively low quantities and high anchors and intuitively high quantities, that's when anchoring effects should be largest. And to one of kind of points I think Derek made earlier, the anchors are kind of skewed, so just because of the kind of limits of the scale. So for low anchors and intuitively low quantities, the anchors are actually usually kind of closer to the average estimate than the high anchors. So this is going to be a kind of very conservative analysis for that reason. Essentially, what we find is that for low anchors and intuitively low quantities, we get larger anchoring effects. And high anchors and intuitively high quantities, we get high anchoring effects. And then for kind of intuitively low quantities and high anchors, or low anchors and intuitively high quantities, you get smaller anchoring effects. And again, this is relatively conservative because the actual distance between anchors and average estimates tends to be a little larger in these cases. And if you control for that, you get kind of an even more stark looking chart. By the way, we can also do that same analysis for study 1, which is even cooler because you can actually see that you can decompose the effects of the intuitive, from insufficient adjustment and changing direction. So again, I'm going to show you kind of the exact same chart as before. The anchoring effect in percentage points is going to be the y-axis, and then I'm going to show you the effect of low and high anchors versus control for both situations in which the correct answer was low and the correct answer was high. Again, so this is confounding people's intuitions about the quantities with their actual value, which that's how I'm manipulating it for now. basically you see the same pattern. It looks a little more pretty than before. But basically you get these kind of big anchoring effects for low anchors and kind of low correct answers, and high anchors and high correct answers, and these relatively small anchoring effects for situations in which the level of the anchor doesn't kind of match the people's intuitions about the quantity. Okay. So to recap so far, when anchors and people's intuitions about quantities are kind of both high or both low, people often adjust from anchors in the wrong direction. And this causes kind of more bias than can be explained by insufficient adjustment alone. Okay. So now I just
Josh,
want, yeah, go on.
Can I jump in? I kind of want to come back to Dan's point from earlier about the question about whether adjustment is actually happening. This is going to be one of those kind of more comment than a question, but I'll invite you to comment. But
yeah, go on.
I'm wondering whether in some ways you don't really care whether there's a real process of psychological adjustment, that really your effect depends on people committing to that first question, which then logically constrains how they respond to the second question. And then you kind of don't care whether there's some mental scooting down a number line or not. Is that right? In that sense, your account doesn't really depend on taking a position on how much adjustment's actually happening.
No, yeah. So this is kind of neutral about adjustment in the case of a given anchor. I think if I kind of understand Dan's point correctly, then it's partly that in that it's basically one critique of this, I think, is that in the unanchored case, it's not actually an unanchored case. There's just another anchor and we don't know what it is. And so maybe people's estimates, for example, are anchored to 50%. In which case, maybe part of the reason we seem to see more people adjusting kind of higher than high anchors, for instance, is that in the control condition, actually people's estimates are anchored to 50%, and so actually it's those control estimates that are biased. So in that sense, I take Dan's point as kind of I would almost describe it as a confound. So I think that what that says to me is basically that showing that people disproportionately adjust lower than low anchors and higher than high anchors kind of isn't sufficient for this theory, and I think it kind of underlies the importance of the moderation by whether the quantities are kind of intuitively high or intuitively low.
So just to offer a little clarification on my earlier point, just because it's come up a few times. I'm not supposing that there's, say, a set of well-defined other exogenous or even endogenous anchors that are true to all people, but that people have other information that goes into the judgment. That is, people can make these judgments without the presence of an anchor, and you give them an anchor and then the judgment changes. It doesn't mean that they're engaging in a fundamentally new judgmental process. It's just that the regular judgmental process that they would normally engage in an unanchored context is the information is changing. And so when you think about what you've laid out here, the intuitively large and intuitively small, well, for it to be intuitive implies that the decision maker has information about elephants and, Nobel Prize winners and things like that. And so I suppose I think what a lot of these questions are asking is, where in this framework are you talking about the information that the decision maker has in hand when you are talking about, say, intuitively large or intuitively small things? You're necessarily implying differential information about the stimulus.
Yeah, so that's, I think you could think about something being intuitively high or intuitively low according to the information people have about the stimulus. I'd say that's so, of course, for like high versus low quantities, there's kind of necessarily different information. So in the case of like, I'm not sure exactly what you're guessing at here. I don't think so. If, for example, in the case of like the just estimating the proportion of pixels of one color or another, clearly, like all the information that people could want for each stimulus is on on the stimulus itself, especially in the case where we use transparently random anchors. And so I think like any effect of an anchor is hard to explain with kind of differential information, if that makes sense. Okay.
Sorry,
yeah, go on.
If I can just give that a shot a little bit. Like, so I think, just to clarify, I think we're completely agnostic. I mean, back to Clayton's point, I think we're completely agnostic about whether or not there's the kind of adjustment process going on that has been posited in the anchoring literature. So we are agnostic as to whether people are actually moving down a number line until they stop at some value. I think the place that existing knowledge or information comes in is determining what people's plausible ranges of values are in the first place. And so I do think this framework for anchoring is very helpful to try to understand it. Like, people have some vague, plausible range of values that they won't go outside of when they're making a final estimate. If the quantity is intuitively large, that range is going to be higher, and if the quantity is intuitively small, it's going to be smaller. But mostly what we're trying to capture here is that normally all of these anchoring theories kind of have this implicit or sometimes explicit assumption that you are adjusting in the direction of what your unanchored estimate would have been from the anchor. And we're like, no, that's not necessarily true. You could actually be adjusting the other direction, which can exacerbate anchoring effects. And so I think like that's kind of where we are, but we are being loose with our language, and that's not just Josh's fault. That's also my fault. But so you're right to sort of call us out and be like, wait, are you really positing an adjustment process here? But I don't think we need to, and I think we're actually pretty agnostic to that. People can definitely bring other information to bear to answer these kinds of questions. But yeah, thanks for your thoughts.
Okay, thanks, Joe. All right, so I'm going to move on now to talking about the directional anchoring bias with respect to purchase decisions. So there is a kind of a bunch of literature already on kind of anchors and purchase decisions, but usually they're in contexts that are different from just there's a price and do you buy or not. So for example, Leif and Hannah with Mina have work on like anchoring and pay what you want contexts. I know that Julia has work on anchoring in kind of house purchases and house prices. But in these cases, there's not just kind of one list price that you can take or leave. It's either a negotiation or people are just literally determining the anchor. They're determining their valuation just directly. But if there's a kind of directional anchoring bias, then this suggests that anchoring might apply just to regular take it or leave it purchase decisions at a list price. So imagine, for example, you're considering buying an iPhone for, say, $800. Essentially, you must estimate how much this iPhone is worth to you. In this case, the price is going to act as an anchor, but your decision is going to depend on the direction of adjustment rather than how far you adjust. So if you adjust higher than $800, that means your valuation is higher than $800 price, so you'd buy. If you adjust lower than $800, then you would not buy, because obviously your valuation would be lower than the price. So again, doesn't matter how much you adjust, it just matters in what direction you adjust. Okay, so let's consider then what our theory would predict about decisions for goods at low prices and goods at high prices. So in the case of low prices, if the price is lower than what your unanchored willingness to pay would have been, but the good has kind of intuitively low appeal, you might not buy even though your unanchored willingness to pay suggests you would. So to kind of make this concrete, imagine you're considering your valuation of a kind of secondhand toaster. Absent an anchor, your willingness to pay would be somewhere within some range of reasonable valuations. But given a low price, it's kind of easy for me to think about reasons why a toaster might not be particularly valuable. So it's possible that you would in fact adjust your willingness to pay lower than the low price away from your unanchored estimate. This would mean that kind of for kind of goods with relatively low appeal, even at low prices, they might not buy even when their valuations suggest they would. In the case of an intuitively appealing good, like say an iPad, well, even if the price is lower than what your unanchored willingness to pay would have been, it's unlikely to move your willingness to pay lower than that low price, because iPads are kind of intuitively valuable, and it's not that easy to think of reasons why iPads are worth less than any given price. So in this case, we'd expect kind of regular anchoring, which wouldn't affect people's purchase decisions. So if people would purchase at that price before they'd seen it, then the price isn't going to change the decision. Okay, so high prices, in contrast, are going to kind of show the opposite bias. So if the price is higher than your unanchored willingness to pay would have been, but the good has high appeal, then you might buy, even though your unanchored willingness to pay suggests you would not. So using that same example of the iPad, with your unanchored willingness to pay in the middle of that perceived range of valuations, if you're given a high price this time, well, easy to think of reasons why an iPad might be worth more than any given price. They're cool products. And so you may adjust your willingness to pay upwards from the price, meaning that you'd buy even though your unanchored willingness to pay suggests you wouldn't. So in general, at high prices, if you're considering kind of goods with relatively high appeal, you might kind of buy even when your willingness to pay suggests you wouldn't. High prices and goods with relatively low appeal shouldn't demonstrate this effect, because in the case of, say, the used toaster, it's going to be hard to think of reasons why you should be adjusting your willingness to pay upwards from the price. So instead, you'd probably get regular insufficient adjustment of your willing to pay, but it wouldn't change your purchase decision. So we're going to test these hypotheses in study 3. We had participants make judgments for 12 goods with relatively low appeal and 12 goods with relatively high appeal. We either assigned them to make unanchored willingness to pay judgments, or we assigned them a low anchor, or we assigned them a high anchor. There's actually some other judgments that they made with where we just had them make hypothetical purchase decisions at those low anchors or high anchors, but I'll talk about that more later. To generate these low anchors, we just took the 20th and 80th percentiles of willingness to pays in each good from a pretest. And to make these transparently uninformative, what we did is we actually told, like in the anchor condition, we actually told participants what both anchors could be, and then just say, we're just going to draw one of these two anchors and have you answer a higher or lower question about it. And then they just did that on the next page. Okay. So in terms of the design, we tell participants to imagine that they were considering buying some good, either a good with low appeal like the toaster, or with high appeal like the iPad. In the unanchored willingness to pay condition, we just simply ask people what's the highest price at which they'd be sure to buy, in this case, the iPad. In the low anchor condition, we'd first ask them if this price would be more or less than a low anchor, in this case around $130. In high anchor condition, there'd be a high anchor, in this case $500. And now I'm just going to show you results for the low price. So the y-axis is going to show the proportion of willingness to pay judgments that are at least as high as the low price. So basically any judgment that implies that they would buy. Okay, so let's start with goods with relatively low appeal. So because of how these low prices were selected, we find that like around 80% of unanchored willingness to pay judgments are higher than that low price, or at least as high, suggesting that they would buy. But of course, when they actually are asked to consider if they're willing to pay is higher or lower than that price, then fewer people give willingness to pay is at least as high. So some people are adjusting their willingness to pay downwards, kind of consistent with this directional anchoring bias. And for goods with high appeal like the iPad, that effect is moderated. Again, consistent with the idea that like for goods with high appeal, when you consider a low price, it's not like you can think of many reasons why you would want to pay less. And so the low price anchor does not make much difference. And you actually see, as I say, we also asked people just for their direct hypothetical purchase decisions at these prices, and they follow pretty much the same pattern. Okay, so now we're just going to look at the same chart, except this time it's the y-axis is going to be the proportion of judgments that are higher than a high price.
Josh?
Yes.
I'm just curious, do your participants think of their willingness to pay statements as literally as you are interpreting them? That is, I know when we ask people willingness to pay, we are really trying to say, if the price was higher than this, you would not buy, and if the price was lower than this, you would buy. But at least in my anecdotal experience asking that question, people don't think they're doing that at all. They're stating some abstract number that represents their conceptualization of how valuable is this on the market, how much do other people pay for it, how much can I sell it for on eBay, whatever. And so I'm just curious if your participants, if you ask them the more straightforward question, okay, so would you actually buy this toaster? Would they all say yes in accordance with the price they just stated? Or would they say, no, that's not what I meant?
Yeah, so it's a good question about interpretation. Of course, very literally, we do ask the purchase decision question, and it ends up looking very much like the anchored willingness to pay question. I think I suspect that in practice, many people are giving these kinds of skewed willingness to pay judgments, which are more about kind of maybe what they think they should pay. It's complicated because, of course, we're asking them to suppose they're in a situation where they're actually looking to buy something. But the idea is, by comparing anchored willingness to pay with unanchored willingness to pay, we're at least using a willingness to pay judgment in all cases. It's, I think, a bigger problem when comparing willingness to pay to purchase decisions.
Okay.
Okay. So, all right. Again, y-axis here is just the percentage of willingness to pay judgments that are at least as high as a high price. Okay, so let's start with goods with relatively high appeal. We find that around 12% of unanchored willingness to pay is higher than the high price. But when they actually see the high price anchor, then we find that around 20% of people say they're willing to pay more than the high price. Finally, goods with low appeal, well, they don't show this bias, so it's hard to think of reasons why something like a used toaster might be more worth any given price, and so we don't see this bias. Okay. So, what are the implications for purchases? Well, people buy expensive, desirable products more than willingness to pay would suggest, and they buy cheap, undesirable products less than willingness to pay would suggest, and that's consistent with the directional anchoring bias we saw in estimates. It is possible that kind of people kind of interpret the willingness to pay question slightly differently across these conditions, kind of relevant to what Leif said. So it's kind of unclear which of these judgments is more correct. It's also worth saying, actually, also to Leif's question, that because people, this was kind of within subjects, they're making these willingness to pay judgments both with and without anchors, which hopefully would make them use kind of the same process, or at least interpret the question the same way across conditions. But of course, it's hard to rule out completely some difference like Leif was talking about. Now, one interesting question is which judgment is better or more accurate. Now, it's of course hard to say, right? So it could be that valuations are kind of a more faithful representation of what would actually be good for participants, or it could be that they're kind of anchored willingness to pay judgments are better. But one thing that is interesting to note is that in general, the directional anchoring bias seems to reduce estimation accuracy. So anchored estimates tend to be more likely to be kind of further from the correct answer when they're adjusted in the wrong direction, which is something you can see from study 1. And that's kind of consistent with some work on anchoring estimates, estimate accuracy, including kind of Jason Dana has some work on this, but his model of kind of what how anchors can increase accuracy kind of assumes some insufficient adjustment type process, or some mix between so the anchored estimates are some mix between an anchor and an unanchored estimate, which can lead to increased accuracy, but it's much harder in the case where people are adjusting in the wrong direction from their anchors. In particular, seeing anchors makes people more likely to make an estimate on the wrong side of them. So if you know, say the correct answer for the proportion of blue pixels in an image is 70%, and I see an anchor of 75%, I'm more likely to make an estimate above 75% if I've seen that anchor of 75%. So if we extrapolate that to purchase decisions, it's possible that prices actually bias consumers' purchase decisions to their detriment. Obviously, this is extrapolating, and it could be, of course, that prices are offsetting other biases. They're, of course, informative. So I'm not necessarily saying that we should dismantle capitalism today. We should sleep on it, and maybe this weekend we can talk about it more seriously. So in sum, anchors affect the direction of adjustment, increasing anchoring effects. People usually adjust higher than high anchors for intuitively high stimuli, lower than low anchors for intuitively low stimuli. And that actually predicts when anchoring effects themselves are the largest. And also suggests that merely giving people prices can bias purchase decisions. And so that is everything. Thank you guys so much.
Thanks a lot, Josh. That was really great. And thanks to all of our panelists for being here today, and to all of our audience for attending and listening and submitting such great questions. And thanks everybody in general. Enjoy your weekend. We will probably be back next week with another Data Colada seminar. All right. Thanks everybody.